Hello everyone, thank you for clicking because this is our first video. Now today we have a very weird question on our hands. What if a proton went through the earth at the speed of light? Let's dive in. Would the earth crack open? Would it make a tiny hole through the ground? Or would the inhabitants of our beloved planet just simply not notice at all? So let's just get a context of our situation firstly, as it's the only wise thing to do at first. First of all, what even is a proton? Most of you will probably know this, but a proton is a part of an atom, which is what makes everything up. Different types of atoms with different amounts of protons, neutrons, and electrons. Electrons just spin around the core. Different combinations of them make up different materials. Now, if you compared the size of a proton to the size of an atom, it's exactly like comparing a football pitch, which in this case is the atom, to a grain of sand, which is the size of a proton. Not so strong now, proton, eh? So now we know how weak the proton could be. I mean, even if it's going at the speed of light, it's probably not even going to do as much damage to the Earth as this asteroid you can see right here. Well, that's totally true, but it's probably going to be way more charged up than you think. Get it? Because it's literally charged. There's just one key thing to remember. Because the proton is so small, it can fit through the gaps between the atoms, the electrons, and everything else, which is space between everything. The proton can easily zip through almost anything in the Earth, and the chance of bumping into an electron on the way is pretty low, but into a nucleus or another proton in the core of an atom is highly unlikely, almost impossible. If that happens, I'll just cover that into the end of the video, but for now let's just go back to where we were. So now let's actually start the experiment of the proton going through the Earth. Before, everything I've said is theoretical, but let's actually start it now. Firstly, the proton has to go through the crust, which is what most of you will know. Now, the crust is probably the second least dense areas on our planet, and there's a lot of space for the proton to zip through, and it might bump into one electron or two, but it will only create a small electric power, and it won't make any vibrations that humans can sense. It probably won't make a chain reaction either. The mantle, which is directly below the crust, that is slightly less denser in some areas and more denser in other areas, as it's only molten rock. It's not evenly spread around, like in the inner core, outer core, and in some places of the crust. So it might go on a bumpy ride, the proton. The outer core is kind of dense, but it's not dense enough to stop the proton from going through. But there's one key part about the Earth that the proton just might not be able to go through, or can it? It's the inner core. Now, I'm seriously surprised if you made it this far through the video. Super thanks to all of you if you did. Now let's just get back to where we were. Are you kidding me? This is the most pixelated visual representation I've ever had to see. You know what, never mind, let's just move on. So we know that the proton can go through the crust, the mantle, the outer core, and the inner core quite easily. Wait, did I just say inner core? Actually, I did. The inner core, although it's very, very dense, so dense that even some protons and electrons bond together and create neutrons, although it's that dense, there's still a lot of space for the proton to pass through. So much, in fact, the chance of it colliding with an electron is still only 1 in 110,000. So, as all of you expected, a proton can't destroy the Earth, no matter how fast it is going. And also, there's one fun fact about relativity at the end of this video about if it actually went at the speed of light. I'm going to mention that in a minute. That just leaves us with one thing. Let's just say a moral of the story. Don't underestimate something by its size, because it can sometimes be unstoppable, like this proton. E equals mc squared. A lot of you will know this expression. It was made by Albert Einstein while he was doing his theory of relativity. But what it means is, energy is another form of mass. What E stands for is energy, m is mass, c is the speed of light, and the squares means the speed of light squared. That means that energy, mass, and the speed of light are innately related. What does this tell us, though? Well, Albert concluded that if something goes at the speed of light, it will need to have infinite energy, because the thing is, he concluded that something with the speed of light will have infinite mass. Therefore, you will need infinite energy to maintain that speed. The faster something goes, the more mass it has. Can this only mean one thing? Well, only then, theoretically, light is the only thing that can travel at the speed of light. Because a proton actually has a mass. Light has absolutely no mass. Just a single light wave, it has no mass at all. No matter how bright or how much light there is, it will never have any mass. That's why light can travel so fast. A proton can never achieve that. But just in case, if it was possible, if a proton could actually travel at the speed of light, then this video was about what would theoretically happen. Hope you enjoyed. And also, we have to do that quiz, I nearly forgot. The first one's going to start soon. A few more seconds left. I'm giving the answers now. There are 118 elements that we know of in the periodic table. This is the final question before we go. It is 1 femtometer. There's other info in the description. Thank you for watching, hope you enjoyed, and we're going to post more videos soon. Bye!